And maybe that's something that we're guilty of, child slavery. Womp! Like that? Yeah. I still think womp, womp, womp is better. Okay, so we've been working our way through these functional families, and you'll notice on the inside cover, front cover or back cover, inside front shows all the, oh, no, sorry, inside back cover then, must be. Yes, on the left-hand side, it shows you example of all of those um, family functions and what it is that makes an aldehyde, a ketone, and whatnot. This is where we left off with yesterday. Okay, so we begin aldehydes, ketones, carboxylic acids, and esters. What, from prior knowledge, what do all of them have in common? That's correct. They all have carbonyl carbons. Aldehydes, it's on the end. Acids, it's on the end. Ketones and esters, it's anywhere other than the end. And maybe it's possible for an ester to be on the end. I don't picture that. My experience with this really isn't that far in depth to answer that confidently, but I would venture to say no, but it's possible. Carboxylic acid? I sure will. You bet. Okay, so did we remember this from last week, or you just happened to glance at this here to say they all have a double bonded oxygen? No, I actually knew. You actually knew that? Awesome. Awesome. Zoink. That nose just jumped up 3 inches.
No, I actually did. I even like low key studied. I wrote everything. Trust me. Trust me. I actually.
See, now you're starting to sound like me, because that's something I tell my wife her favorite 2 words. Trust me.
Well, trust me. I did it.
Okay. Okay. No, I sounded like that was rather entertaining, but it had a safe and happy ending. So. Mm, mhm, mhm, mhm. Well, that's what this remote is for. Just to see who's paying attention and who isn't. But you evidently are. Okay? So, one of the aspects, one could argue, you're probably going to learn this more efficiently just by looking at the examples. I would have a hard time arguing with that. But once you write it down and you look at it, it doesn't make any sense. But then when we write it down on the board and then you take that definition that you have, then I believe that makes sense. So we'll be doing that here in just a couple of moments. Expand on some of our derivatives and then give you an opportunity to perhaps look at your papers that are due tomorrow in case there's something. I know on that first paper, there's, I believe there's some alkenes on there, which yes, I know we haven't talked about yet. We've only made a reference to them, so we'll be doing that also here in a couple of moments. Okay, so I want to do this one. I just want to get through this one, then we'll start looking at some of them examples we were talking about. Okay. Now, the naming of these compounds will become more and more common the further we get down the road, which I think you would also agree would make sense. I have all these textbooks in here because at one time it was going to be believed that we were possibly going to have close to 8 students in here, but that, no, this would have been a couple years ago, but that had fallen through. Oh, well. So it goes. Now, when you individuals go and take this class in college, you, you may even use a textbook like this, because notice on the cover it says General Organic and Biochemistry. So probably the first, I want to say 6 or 7 chapters or so, maybe, no, more than that, probably the first 15 may be devoted to just that of general chemistry. So when you maybe see, I don't have it written up there at this point, but it may say signed worksheet 1 or worksheet 2, chapter 3. What that means is it's making reference to the same author, the same textbook, but instead of a hardcover, it's a softcover book like this. And I see I lost the cover to it. But again, same author, just says organic and biochemistry. There's a little bit of a review of general in the front part of your book. And when you take this class next year, one of you, or it might be next year, hard to say, you may do some reviewing of that of general chemistry. In other words, limiting reactants, stoichiometry, all that good stuff. So again, if you're looking up here and it says worksheet 3, chapter 3 or chapter 4, and ask what that might be, because right now we would be at or around where it would say part 2 in this book. It says organic chemistry, which begins on page 291, which is actually chapter 11. Okay. So, go ahead and look at page 295. And notice there it has a breakdown of all of the different organic families. And we will go ahead and look at some examples of those. So what I want you to do is think about those definitions that you had wrote or written down, and we can put those to good use. Okay, so for instance, go ahead and pick any one of those compounds. An ether, okay? So what does it say the definition of an ether is? There's got to be a double bonded oxygen because we know it's a carbonyl atom. Okay, so what that would mean is we're going to go ahead and stretch this out. Okay, did you say ester or ether? Okay, so in this case, an ether then is in the middle. Okay, they don't necessarily have to have the same number of carbons on each end. You can have one on one side and 7 on the other, just so you have that single bonded oxygen somewhere other. Well, you can even have it on the end, but you can't have it on the outside here because oxygen would not have enough bond unless it was double bonded. Yes? I do, and in when you're asking that, remember this is not a hydrogen. It's a carbon to oxygen bond, same with this one. So the reason that's important is we can go back and say, okay, so X marks the spot. Since this is not a hydrogen atom, this is a derivative. This is also a derivative. So, with that being said, what is a 2-carbon derivative? Okay, so over here we've got that, and what we got P.
Yeah.
We got P, P-E. I don't know if we need either P-E-E or P-E-A. I get that, but so what that is saying is now you would have to put that in alphabetical order. You have ethyl, propyl, ether. There's no numbers involved because we know that an ethyl group has 2 carbons. We know that a propyl group has 3 carbons. So you would not have to specify where that oxygen is. You don't put any numbers in saying 2 ethyl propyl ether. I mean, ethyl propyl ether. So of course at this level we're not concerned with naming them. What we are concerned about is looking at this and saying, okay, there's a single bond oxygen that's not on the end, therefore that is an ether. Okay, next compound. Okay, so an ester would be closely related to this.
But it's got a double bonded oxygen. Not.
So you're close. So we can just do a 3-carbon atom. We're still going to have that single bonded oxygen there. So what I want you to do is say left or right. Okay? So what that means, we can safely make this that ethyl group. So since you said left, that double bonded oxygen, which one of these carbons is that going on?
To the right.
Yep. So now when we look at this, we've got our ester. Okay? We're not going to really go into the name of that. But if you really, really needed to know, it would be, I believe, ethyl propanoate. So we will cover that. That'll be right away in January when we come back. Right. The only thing you're concerned about is recognizing the difference between these two. Esters have a carbonyl atom, ethers do not, because that oxygen is not on the end. Okay, next one.
Acid.
Okay? So, pick a number between 1 and 5. Or 2 first.
Oh.
Okay? So, with that, what does the definition of that acid say? And you can also look on page 295 to give you a little bit of a clue should you need that. Okay? So, you want it on the left or the right? Okay? So there's our carbonyl atom with an oxygen. But what else do we need to put on here? Okay? So the reason I say that, would that be a stable compound right now? Yes, it would. And it's a different functional family. That would be an aldehyde. So we're doing an acid though, so we got to put that OH group on there. So there's our acid. That's ethanoic acid. That's correct. Yep, yep. So next functional group. And we don't need to go through all of them. It's if you feel more comfortable going through them, that's fine because we have illustrated some of those. No, we're not concerned about that.
We're not doing mine.
Correct.
Right. Okay. Are we doing carboxylic acid?
That's this one. Carboxylic acid.
Oh, so it's just like same thing as an acid.
Yes.
Oh.
Yes. Okay. How would you change this ethanoic acid to ethanol then? Yep. So we're going to take this guy off. Okay. The oxygen, and then just put 2 hydrogens on there. Now we've got ethanol. Yes. Yes.
It has to have the same carbon as the oxygen.
For an acid? Yes.
We got it. I think we got it. Ketone, aldehyde.
Okay. And we can change this back to close to an acid, but an aldehyde, we would take this off. This OH is gone. Aldehydes don't have an OH on it. It's got this instead. That is an aldehyde. Yep. Then we would just add another carbon on there.
So all the organic families include the alkane, alkene, ketone,
I believe so. Let me. Okay, you could say 9 depending upon whether you want to count the aromatics as one. We really don't spend too much time with that until we get into next chapter.
Okay, so like aromatics and things like.
Yeah, it's a ring structure instead. Yes. Okay. Okay, then finally I want to do something like this. Okay. What organic family is that? It's an alkene. Okay. So with that, you establish that correctly as an alkene. So what does that mean to be an alkene? Okay. Now, where does that double bonded carbon to carbon bond have to be? Not necessarily. Any one of these. It can be any of them. Now, the reason that we put it on the end is you can be really, really specific if you want, or you can say this just has a common name. The reason I say that, the best way to look at this, do you remember what sulfuric acid is? It's some H. Okay. So, do we put a 1 after this S? No. It's just understood that if you're writing the S, that's accounting for 1 atom of sulfur, correct? It wouldn't be wrong to put that in. I just think, maybe as younger people ask you a question that in their minds they're serious, but it's such a simple one that I can't believe they just asked that. And it happens. Maybe throughout the course of a school year, maybe it even happens for myself. But it's just understood then that I think if you wrote that down in a college classroom, they're not going to count it wrong. They're just going to scratch their head and say, "Where did you go to high school?" And yeah, that's why you take the Coleman Egan Hawks shirt off and put Chester on there or something like that. So, the reason we say that is since this is what we say on the end or the beginning, whether you're reading this way, it's just understood that in the naming, you're not saying anything other than this is going to be on the first carbon. So with this, your parent chain is still what? Okay, so we know we've got hexene. And is there anything branching off of that hexene? Yeah. So we've got 3-methyl hexene. Now, again, if you really, really wanted to be specific, you would just put a dash, a 1, and a dash. It's not wrong, but in that, I think, would be a little more, I don't want to say acceptable, but they say, oh, yeah, well, they're just really being specific here in this account. They'd say, where did you learn that? Because you probably wouldn't ever talk about it this way at any level. But this would be fine. This one kind of, oh boy, I got to spend some time with this one maybe.
So like if that double carbon is like on the fourth one, then we just put the fourth instead of the hex.
Okay, so if that's the case, now we got to be careful with that because 1, 2, 3, 4. Okay, so if you're going to put it after the fourth one, is that what you meant?
Yeah, so then it will actually.
It's after the second one then. So that's the only thing you really got to be careful of is you're switching that double bond around. You're going to want that lower number. But yes, you are correct. Okay. So if there are any alkenes on there, hopefully that straightens out any questions, which I think there's one. You're just naming where that double bond is. You put that number after the number. Okay. So what I mean is if that double bond was here, it would be 2 then, okay? So these are gone, and then we would have to, we could just write it like that. Then that would be 3-methyl 2-hexene, okay? If you're moving that double bond over one. You put the number after the carbon that has the double bond. Okay. Then, are we on the bus here so far? All right, so the last thing I want to do, okay, you turn to 297, okay, no surprise there. It's just drawing all of the common, what does it say, table 11.3, formulas and properties of normal alkanes, just straight chains, that's all it's saying. And it gives you some of the physical properties. It gives you just the number of carbons, and they're writing out the molecular formula and then condensed structural formula. So what that means is if we're talking about propane, okay, a condensed structural formula for that would be this, okay? We know that the molecular formula is C3H8, okay? But if we did a condensed structural formula, it would be CH3, CH2, CH3, okay? I've always looked at those. We have experience with it? Yes, but I would suggest not doing that. Now, when you take that in college, does that mean will they refer to it that way? Possibly. Okay? But to me, you're never wrong by writing out, rather than the condensed structural formula, the expanded structural formula. And And what that would mean is you're talking about the same exact compound. To me, this is just a little more precise. You're counting for all three hydrogens, those two hydrogens, and then those three. These mean the same thing, but I prefer you use that. Do I know what you're referring to if you use this? Yes. But you're really, in my opinion, going to confuse yourself. Now, you might be thinking, well, if that's what we're going to be taught about in college, well, let's make sure we have a very good understanding of this first before we start diving into this type of a formula. Because if you really can relate these two, this I think will come in due time. But I don't use this type of formula. I may use this one or this one. This is the one I suggest that you use. Okay, so moving further, some of the derivatives. They call them alkyl groups. I prefer derivatives. Page 308. Okay, table 11.4. Okay. Remember, we said as a freshman, you need to know the first two, a methyl group and an ethyl. Then they show you the formula in that table and then how they would attach. Then last year as juniors, you learned the propyl and isopropyl group. It gives you those structural formulas as well. And then we add four more derivatives, your butyl groups, okay? Plain butyl, secondary butyl, isobutyl, and then finally tertiary butyl. We're not going to dive into that today, but we'll certainly make reference to those later on down the line. Possibly hand that out, go over some more of these tomorrow, okay? So, with that, you have some papers that are due tomorrow, and then you'll get some more to work on tomorrow. Okay. Any questions over what we've done today? Okay. So you can go ahead and ask any questions you feel you may need to, or use this time to wrap up what is needed for what's due tomorrow. All right. We will catch up to you next time.